My name is Roy Benalta. I'm from Amazon Web Services. I'm here with Dr. Ira Cohen from Anodot. And today we're going to talk about the real-time journey from raw streaming data to AI-based analytics. So we try to push all the buzzwords into one title so we can get you in. But what we're going to do today is, so just an introduction. I'm part of Amazon Web Services. I've been 4+ years. I'm a solution architect, and also I'm responsible for our KINESIS business, also part of our machine learning team, working with many customers all over the world about implementation. So we're going to talk about some real-time use cases and trends. I'll talk some about Amazon KINESIS for those that are not familiar. Then we'll have Dr. Ira talking about Anodot case study. We'll show you a live stream what is anomaly when you try to purchase a product on the website and there is a price glitch, and how you handle these anomalies in real time. We like to do some real-time demos, so hopefully you will enjoy that. So take your phone now and go to this website. We'll start with a little game. So it's http://amzn.2/big data. So your phone is going to be like a sensor device that we're going to play a game with a ball. So raise your hand, anyone that is on this website and can see a blue ball, right? So you're using the gyro of the phone so you can move it from different coordinates. So you're all there, right? So who else is there? Just raise your hand. Okay, so we have, okay, and this is us. Okay, so, oh, I need to switch to, so left side, everybody go to A. Just place your ball on A. Let's see you in real time. A, left side on A. Right side, go to D. So this is you in real time. I can actually see some of your, how many visitors you can see. I can see that most of you has Android. I can see more than 50%. But this happens in real time. So we have around 90 people now. And we'll get to that demo later on, but this is one example. Now, we all love AI, so now you go to this website, and what I want you to do is to take a selfie. Now, don't worry, don't store your pictures. Go to this website, http://amzn.2/take-selfie. So this side, smile when you take this selfie. This side, don't smile, just take your selfie. Anyone on the website already? So yeah, I can see people take selfie. So it's the same URL, but you now just taking selfie. Okay, so take the selfie again. Sorry about that. So now we'll see a dashboard of the labels that our Amazon recognition actually takes. So 40 of you, I missed some of you, but if you take the selfie again, you will see the numbers. So we can see it's Women's Day today. We see less women than we expected, only 7, rest are male. You can see how many people are wearing eyeglasses, like me. So I think it's 50%. Half of you hipsters with beards will identify. By the way, about the age range, I don't take any responsibility. This is how the model, we give an age range. So some of you are maybe happy, some of you are not. But and so what's nice about this demo, so you can do view source later on and see the code. It's less than 40 lines of code. But it's all about real time and stream and, oh, shit, okay. And when we develop real-time streaming, there's always like 3 stages or 4 stages. First, we need to ingest all this data. And what is interesting about real-time, that the data is relatively small. It can be bytes, kilobyte size. We need to gather it from many websites, clickstream or logs, but then we need to persist it on the fly, and we need to do something with it. So in this demo, we just analyze the labels and we show a real-time dashboard of what you're doing, like selfie, but it can be anything. It can be the cars, it can be your machine at home, it works. And working with customers all over the world on real-time streaming, what we've seen is that there are many common use cases, from security monitoring, your log analytics, building data lakes that I need to take all these data, sometimes change data capture, changes on your database. These are really small events that I need to capture them and add it to them. Now, the challenge with real time is really, it's a hard problem, right? So everybody did computer science, messaging bus, but there are some requirements. We need to have a persistent storage. We need to support the continuous streaming of data that goes into your system. Needs to be fast, right? Latency is important. Sometimes 2 or 3 seconds, it's not enough. We need something that on the milliseconds, depends on the use case. Order is important. We need to be reactive. So there are solutions today. Kafka is one of the Apache Kafka. How many are using Apache Kafka today? Raise your hand. We have many. How many are using KINESIS, by the way? Okay, we have some hands. How many are using AWS and not using KINESIS? Okay, so I want to tell you a story. If you're using AWS, you're using KINESIS because Amazon KINESIS is a foundation service of AWS. On every region, you have KINESIS data streams. And these are some of the services, like if you're using IAM, Amazon's S3 events, Amazon CloudWatch, like we're probably all familiar with CloudWatch, they're all built on top of Amazon KINESIS. The history around it is that we had to build our own metering system to make sure that we can measure and meter all the traffic that runs on AWS. In 2016, actually, we went public and we talk about that. Just for the metering, we're running like hundreds of millions of events per second just to ingest. So one thing I want you to remember that KINESIS is a foundation service of AWS. However, we have customers that are using Apache Kafka, but you can also use both because we also build a connector for customers that are running in a hybrid mode. You have Kafka in your data center, you need to stream it or fan out the data into something like Redshift or Amazon Elasticsearch, so you can use the Kafka to KINESIS connector. The slides will be available for you, and I also put the links if you want to look at GitHub and take the code. And you can use both, and we have some architecture topology that you can just install it with CloudFormation. Many customers are using KINESIS. I don't want to get into this marketing slides, but what is interesting is that streaming becoming the new normal for analytics. Right? In the past, I remember my first Strata, everybody talked about Hadoop. Then Jason Martz came about the Lambda architecture and fast data or cold data, but it became like standards. We want to get real-time insights for our business and what we do. And Amazon KINESIS platform today has 4 services that is available for you as API. The first one that I'm going to talk about it, and it's not the focus, but I will just show you like where we are heading also with services, KINESIS video streams. So we're talking about video, and I don't know if you heard about this place called Amazon Go. If you're in Seattle, just go check it out. It's open to the public. Amazon Go, and you know what? Instead of me talking, let me show you a video that I took in Seattle like last week. So, sorry about, but this is me going into the store and buying hummus. So, you walk out into the supermarket, you pick up what you want, you don't scan anything, right? We wanted to build something that is quite interesting that, you know, you have a lot of self-checkout. But the idea is that no lines. We want about speed. So this is me taking the product, go outside, I didn't scan anything, and leave. When I left, you actually get your invoice, and you see they're on trip. So it took me 39 seconds to buy hummus, and this is how much they charge me. And that's one of the services. So in order to build something like that, you need to use AI. You need to use deep learning. You need to do a lot of things with videos. So if you go into the store, you will see a lot of cameras, etc. I will not get, I'm not part of the Amazon Go team, but if you read in the Wired magazine, it's one of the products that Amazon is building and now extend and actually give you the same technology. And Amazon KINESIS Video allow you to take any camera. It can be your Android phone. It can be an IP-based camera that you're buying, you know, online. Connect it to the internet, and now you can stream video to KINESIS video streams, and now you can build your computer vision application, whether you're using TensorFlow, Cafe, in Japan they love Chainer, for example, but you can also use the Amazon AI recognition. So the sample that you saw with the selfie You can actually build an application that identifies faces on the video and send you alerts. Think about you want to build something on the store. I want to recognize who get into the store. The Washington County Police actually using this recognition technology to find people of interest. So they have an index of criminals or people that they know that they did something bad. And for example, they actually show an example of someone goes to a store and they actually found him in relatively 10 seconds because it was in index. But today the focus is really talking about the anomaly detection and machine learning for actually on the data side. And today KINESIS provides you like 3 services, KINESIS Data Streams, KINESIS Data Firehose, and KINESIS Data Analytics, that each one of them has different purpose of what it does in life for your real-time events and processing. So it's a fully managed service. For those that like Kafka, you don't have here zookeepers, no broker, no maintain, it's serverless. You don't need to manage anything. With KINESIS Data Streams, it has what we call shards. That's the concept of how you add more shards or remove shards, but it can support from 1 event per second to millions of events per second without you really have an admin that needs to manage it. Some of the patterns of what customers are building with KINESIS data streams, you can do a real-time ETL, or you can just fan out through KINESIS Data Firehose data to your S3 if you're using a data lake concept. If you are using things like Spark or Storm or Flink, Spark streaming, so you have these connectors available for you also to interact with KINESIS data streams. And you can use KINESIS Data Analytics that I will show you, and also here I will demo what we do. If you're using other third party, so yesterday Disney actually showed a use case how they use MemSQL with KINESIS together and with Looker to build a pipeline for real-time ingestion. But there are many other third party that you can use today. This is part of the list, so we have on our website the list of them. KINESIS Data Firehose was built to do something very, very simple. Just to take your streaming data and send it to an endpoint destination. It can be Amazon Redshift, it can be Amazon Elasticsearch, it can be Amazon S3, and we also added Splunk. So if you have a Splunk that's running in your system, you can actually connect to your Splunk cluster and stream it continuously. The way it works is that you don't need to provision anything. It's four clicks on the console, and it's a set and forget service. So you can say, I want to have a delivery stream to this destination. We charge you 2.9 cents per gigabyte. And these are a lot of events, many events that you can send in 1 gigabyte. And let the service, it deals with retry, deals with, you can set up the compression if you want. Security, it's also an important thing. So if you can bring your own keys using KMS if you're familiar on AWS. And you can build a pipeline which is a serverless, purely serverless ETL with KINESIS Firehose. So what we added last year is also the option of using Lambda. Lambda is our serverless compute service that you can just write the piece of code, whether if it's Go, Java, Python, we support many programming language, and you can do like an inline transformation into the stream. Sometimes if you deal with messy data, you want to do things like IP to country, for example, and you need to clean the data of time format. So before you land the data into the destination and the persistent storage, you can actually invoke a Lambda function that will execute that transformation. The next service is KINESIS Data Analytics, and what KINESIS Data Analytics does for you is taking it to the next level. If you are not Spark Shop or not Flink, but you have a very good SQL developers, and you just want to build an application using SQL, the demos that I show you in the beginning, it's only using KINESIS Data Analytics. So what we did, I wanted to build the windowing function, right? The sliding window or tumbling window. So KINESIS Data Analytics provides you to be able to build an application using SQL language. So what it does, it crawls the KINESIS data stream. Yesterday there was a workshop, I don't know if you attended, but there was a hands-on workshop at Strata to go through, but this is really the service that allows you to build that using a SQL. We also added anomaly detection. So yesterday was a talk about random cast forest. So this is like the executive briefing. Basically, you can do anomaly detection using an algorithm that Amazon wrote, and we're using it in the different places at Amazon, that you can do anomaly detection with explanation and hotspot detection. However, because KINESIS data streams is really open, and we allow many other third party to integrate with us, I think Anodot is a really interesting company that's doing it in a very interesting scale. And they build this connector between KINESIS data streams, using KINESIS data analytics to do the aggregation, and using their platform for using machine learning on real time. So with that, I want to invite Dr. Ira Cohen to talk about from real time anomaly detection to no more blind spots. So thank you for me. Hopefully you enjoyed, and enjoy, Ira.
Thanks, Roy. So yes, first I'll describe a little bit about Anodot and what problem we're trying to solve with our system and anomaly detection. So the pain is really that you don't know what you don't know until you know it, which means a lot of times companies have issues that go on and that can be detected in the data, but they're missing it. They're finding it very late because you're either looking at dashboards or looking at reports, and those come very, very late. And all of these lead to significant loss of either opportunities, customer loyalty, branding, and financial loss altogether. So the existing solutions, the existing BI solutions are, I call them dashboard hells, because you collect all these huge amounts of data about all the events at high granularity, your revenue at every country, and the number of users you got from every platform. I mean, look at Roy's dashboard. That was a very simple dashboard, just already with fine granularity about gender and age and this and that. And when you put everything on dashboards, first you start getting huge amounts of dashboards with lots of charts, and people have to look at those constantly if you want to really get any insights out of them. And if you have things that are time sensitive, real time, or even with an hour delay, it's just a nightmare to go with these dashboarding solutions. So that's why we have machine learning algorithms that can plow through a lot of data and highlight what's important. So this is what Anodot does. So we use unsupervised machine learning to learn all the data's normal behavior, identify abnormalities, anomalies, because those often indicate what's going on. We score them and we correlate everything that is affected to give you a story of what is the anomaly, so you can investigate quickly and identify what's the problem quickly. Just an example, whoever uses any ride-sharing application, you probably know when the weather goes bad and you try to order a taxi or any type of ride-sharing application, oftentimes you end up like this lady standing out in the rain waiting for that ride. Now, what's the problem? So let's say you're a company that's doing ride sharing. You're doing it in a lot of cities. You have your NOC people sitting in front of all these charts, and this is one city out of maybe 100 or 200 different cities that you operate in. How do you know that somebody's looking at what's happening in that city right now if you have those charts? So at the end of the day, you end up with customers that may be standing out in the rain waiting for their ride. Now, how would it look like if you had an anomaly detection that alerted on things? So first of all, if you look at the charts, you can actually identify the anomaly. So the top chart is driver utilization in Nashville. And when you look at it, you actually see that there is a bump in driver utilization, meaning more drivers are on the job, so it's harder to find drivers. And you see that the wait time increases. Now, if you get notified about it early on, you can do something about it. For example, incentivize more drivers to take more rides, increase the prices, search prices, which a lot of these companies do automatically. But at the end of the day, search prices are not that great because you want people to take the rides. So you want to have enough drivers available, so you want to incentivize the drivers to go out when such cases happen. And if you're operating in a lot of cities, you have to be on top of these incidents all the time. And the only way to really do it is to automatically discover them and get alerted on them. The way of looking at dashboards is really not the right way. So how does Anodot work? So the way our system works, data gets sent to us in the form of time series, like the ones you see on the screen here, and our system automatically starts learning what is the normal pattern of it. And the normal pattern is you can see the normal pattern based on the shaded area around the time series. So the solid line is the actual measurement, and the shaded area is the confidence interval where our system believes that measurement should be at any point in time. And whenever there is a deviation from that normal range, like the top one, the orange lines, that is an anomaly. So our system finds the anomalies in all the different KPIs, but then also correlates them so root cause becomes easier. For example, the top one is how many payments were completed for an e-commerce. The bottom one is, and you can see there's a drop in number of payments completed. The bottom one is the number of API errors to a certain payment provider increased. By correlating them together and showing them as a single story, actually the user, the analyst or the business operation person at that company understands that there is a business impact, less payments, and the second metric tells him where to look. So there are more API errors for eBay. Let's go look what happened with eBay. Why is our API breaking more than usual? And that's really the crux of what you need to do if you want to both get the information about what's happening and where is it happening. So why is all this hard to build a system like that? So there are a lot of requirements that you have to think about when you're building a system for a company, for a whole company, looking at any data set that you might be measuring. The first requirement is it has to be accurate and robust, and that's not, that's obvious from any machine learning system, but what's special about anomaly detection? So when you're alerting people about things that are happening, false positives are a killer. I mean, people, if they get alerted on false things, they stop looking at these alerts altogether. They get fatigued by the alerts, and the system becomes stale and not useful really, really fast. To minimize false positive, you have to really be very robust to a lot of different types of signals that might come in. So there isn't a single algorithm out there that you can say, oh, if I use that algorithm, it will solve all anomaly detection problems. There are a lot of different types of behaviors of different signals, and we see quite a few of them. You have to build a system that is robust to all types of signals. To be robust to changes. A lot of companies, the measurements that you have change all the time their behavior, and you have to be robust to them. So, for example, if I'm a company that's doing sales of a product, e-commerce site, and now I did a campaign or I did a rollout of a new capability, I might see an increased number of users that are coming into my system and buying stuff, and that may sustain for a long time if the system doesn't change. If a system that does anomalies doesn't change to those type of normal changes, then you're going to have a stale system that will have a lot of false positives or not detect anything at all. Has to be scalable to millions and billions of these time series, because that's the way businesses go. You want to measure things at high granularity, not just a few single metrics. And it can't be something that people have to configure all the time and touch all the time. Otherwise, it's not scalable either, especially for large amounts of data. And today, our system handles around 300 million time series in parallel for all the customers. If we had to put, or the customers had to put, people sitting down and configuring every single time series, what algorithm to use, or all sorts of parameters, it wouldn't be a useful system at all. And of course, the last one is being able to investigate problems. So isolate and correlate related anomalies so you can easily explain an issue. So not just about detection, but also about explanation. Some of the use cases that we see from our customers that are very typical: online payments and loans, ad techs. The real-time aspects of ad techs is really, really important. Telcos and e-commerce. These are just a few interesting verticals with their use cases. To give you a sense, so we're a 4-year-old startup. We started selling the product about 2 years ago as a SaaS offering. And these are some of the customers, and you can recognize some of them. And really their use cases are all around the business type of metrics that are very hard to monitor manually in any way. and they have to react to things very fast. So attic spaces, either e-commerce or online services like Lyft, online gaming or mobile gaming like King and Social Point and Outfit 7, financial services. So all of them, they really have to, the business operations has to react fast to things, and they cannot wait around for reports or people or customers to complain, which is unfortunately the most typical ways problems are discovered today in a lot of businesses. The customers complain, and then you say, oh, now I realize what's happening. Just to give you a sense of the architecture, and I'll explain why it's important. This is our architecture. We are on AWS, and the way we build our system to be real-time anomaly detection is that we do most of the learning of what is normal and detection of the anomalies on the stream itself, on the stream of data itself. And that's really important if you want to both scale out and also be able to provide anomalies in real time and alert on them. So I'll come back to this. The point is that our data sources, we can connect to any data source. Anything that produces time series, we have a connector to. So these are some of the examples. And I think today, so if you look at the list here, and it's a wide list, a lot of these sources are actually, I would call them data at rest. So for example, if I'm looking at Redshift, it means I already put my data at rest. If I'm looking at Vertica or any type of SQL server, Hadoop, even if I look at Mixpanel for web analytics and Google Analytics, the data is already went through some process and went into rest, which means when we pull it out to send to Anodot, there is already some delay in it. The nice thing about services like KINESIS or Kafka streaming, but we're going to talk about KINESIS specifically, is that you can actually tap into the hose, the actual pipe of the real-time data and stream it into a service that does anomalies. And really, when real-time is important to you, that's critical. You don't want the latency that comes out of the other types of services. So what we like about KINESIS is that there are a few aspects why we have customers that use KINESIS. And again, I'm not part of AWS, so I'm just giving you the highlights of why they like the journey using KINESIS. Because it's serverless, there's really a little work that has to be done on the customer side to get those events to us. So one of the issues when integrating to any type of service is, do I need to use my IT? Do I need to have developers? Do I need IT to give me some servers and access to a cluster? Then I need some developers to develop something as well, some code. And with KINESIS, really, all you need to do is SQL. So I'll describe now, I'll do a demo and describe how you can connect KINESIS to Anodot and get real-time alert for a specific use case. So what I want to demo today, and this is a live demo, which is always scary because I need to generate the anomaly on the fly. And you'll see in a second how I do that. I hope it works. Price glitch. So this is a very common thing that happens in a lot of e-commerce. Somebody posts, because of some error, somebody posts on the website some item, some product for a much lower price than what it should be, and then you get all these scanners scanning the various e-commerce sites, posting it on social, posting it on Twitter, posting it on Facebook, and then people pick up on it and they go quickly to the sites and start buying, right? So price glitches actually cost e-commerce quite a lot of money during the year because people mistakes happen, and that's fine. So let me switch out the presentation for a second. So imagine you're getting an alert from your favorite price scanner glitch app telling you there's a laptop that you can now buy for a fraction of the cost. And let me switch. So what I'm doing now, I'm actually generating the anomaly, meaning that now you all got the alert, you're going to that website and you're starting to buy. So basically there's going to be an increase in the number of users buying a laptop, but the price is much lower than it used to be. So now the data is starting to be sent through KINESIS into Anodot, and I'll describe how that flow works in the presentation, and then we'll see the end result in a minute. What happened with that? So this problem is now started. You want to be notified about it within a minute, ideally, right? As soon as it's detected. So how do you actually connect these business events to KINESIS, to the KINESIS, not Steam, but Stream? So you have your app. You're already collecting events about everything that's happening in that app. For example, add to carts and clicks and buys and what is the price for each one. So these are actual events that go into the KINESIS stream. Now, so you define that stream, the data is flowing through that stream. Defining a stream is really, really simple. And then you go into your AWS account and you create a data analytics app. What is that? Basically, you tell it, it's 3 simple steps. You tell it what the source of the events are. You create an SQL that aggregates that source into, so aggregates all these events, how many buys were there of laptops, of other types of products, and so on. And you define a destination. In this case, the destination is back to another KINESIS stream. So that's the first step. It takes, as long as you write the SQL, it takes a few minutes. And then you create a Lambda function. So you actually creating a Lambda function, again, is very, very simple. It's just opening, saying, here's a Lambda function. It reads from that stream. And we provide code, 50 lines of code, that we actually provide our customers, which take that stream, transforms it into our Anodot API format, and sends it to Anodot. And that's it, you're done. Once that data flows in, you can start detecting anomalies in real time. And let's see if we already got that alert about the price glitch. So it should be, yeah. Let's see. I don't know if a minute passed already or not, but hopefully there isn't such a latency. Well, I'll show you how an alert looks like that I did this morning, which did work after 1 minute. So an alert is something that looks like this. It's basically an email telling you there's a suspected price glitch. And what you see here is that there is a 426% increase in the number of clicks of laptops, in the number of add to carts of and this is actually the price. So you can see the normal price is this line here, and here there was a drop in the average price of this product being sold, which is surprising because you expect if you sell more, you expect the price to stay the same or maybe even increase. So you get this anomaly within 1 minute. Let's see if it's already the new one came in. Nope, not yet. It usually takes at most a minute from the time I started, but it might have not worked that sent. Once you get that, you can investigate it, go into the Anodot system and investigate the anomaly and view it with more, with ability to zoom in on the graphs and look at it carefully. Actually, here, this is the anomaly that just happened. I guess the email was, this is the anomaly that I just created. So you can see after 1 minute, it's already beyond the threshold of the baseline, and it should have sent an alert. It might have been slow in sending that alert, that demo alert. Yeah, live alert, live demo is always dangerous. But in essence, it's probably waiting somewhere, maybe in my spam. You would get the alert. You would see all the metrics that are relevant. We show you it's related to laptops. The number of events for add to carts and buy and clicks increased. The price actually decreased if we look at it this way. So the average price decreased, and this is something that I ran in the morning. And then you can go and fix it, and everything goes back to normal after that. And that's really the flow of how things work in real time. Something happens, events get sent, they get aggregated, get sent to Anodot, we find the anomaly, we alert on it, you go into the system, you see it, you fix it, everything goes back to normal, and without you having to have an army of people looking at dashboards, looking at all sorts of things that they will miss this, because you're not just selling laptops, you're selling 1,000 other different products. So that's the idea. So we're going to wrap it up now. So just to summarize, so real-time data streaming becoming more and more critical to a lot of companies to understand what is happening and react to it really quickly, and not being reactive after the fact or very late to it. Anomaly detection is the advantage. It has a lot of different applications in security and fraud and business type KPIs and so on. The main crutch of it is to detect the unknowns, to detect the things that you did not think about, and even if you had models for detecting all sorts of situations, it would detect the things that those models do not capture. And of course, there are future applications like video analytics, IoT, and the tagline that Roy wrote here, the future is now and it's fast, which is true. It's becoming faster and faster.
Yeah.
Thank you. So any questions?
Yeah, thank you very much. So on the context of future applications, so you saw the video, so we work with several researchers on computer vision. There are companies on deep learning that are doing anomaly detection on video. So think about street camera, you have cars driving on this direction, another car to a different direction, identify anomalies on video. So there's no really limit of how you use machine learning and deep learning today on this type of data set. So I think time is up, so we will be here. If you want to come and ask questions, we'll be here to answer any question. Thank you very much for joining. Hopefully you enjoyed that.
Thanks.
Thanks.